Abstract classes are used to provide partial class implementation that can be completed by the derived class. You want to think about abstract classes as classes that are halfway done. They've got all their members, but they're missing some of the implementation. What they are doing is they are being derived from a derived class. They're being inherited from a derived class, and they're expecting the derived class to actually fill in the implementation. Abstract classes can contain abstract members. Those are the methods and properties that don't have any implementation. They're not yet complete. But an abstract class can also contain non-abstract members, just regular run-of-the-mill members that have both their signature and the code inside. Abstract members and properties do not contain implementation. Those abstract methods, you must use the abstract modifier to denote that the method is just a signature and there's no implementation. Now, don't forget, you can only have abstract methods in abstract classes. You can't use the abstract modifier within a regular class or what's called a concrete class. Derived classes must implement all of these inherited abstract classes. If an abstract method has abstract classes, when that derived class inherits the abstract class, it's got to implement all of those inherited abstract classes. It can't just pick and choose which ones it wants to implement and which ones it doesn't want to implement. These types of classes are only intended to be base classes of other classes. Remember that these abstract classes are not complete yet. They can't be consumed. They can't be instantiated. They're only there to serve as base classes for other classes. Let's take a look at a comparison of concrete classes to abstract classes. Concrete classes are just your normal vanilla classes, and you can instantiate those and you can inherit them, of course, as long as they don't have the keyword sealed. Sealed would mean they're not inheritable. Can you change the implementation of a concrete class if you were actually to inherit from a concrete class? The answer is yes, as long as the method is virtual. Remember that a concrete class will put that qualifier or that modifier in the method definition if it allows you to actually change the implementation in a derived class. An abstract class can't be instantiated. That's because it's not complete. It's not finished. The implementation, or all of it, is not there. So the big difference between a concrete class and an abstract class is the ability or the inability to instantiate or create an object from it. Of course, you can inherit an abstract class. That's the whole idea of the abstract class. If it's not instantiatable, it definitely has to be inherited, and it is. Now, notice the difference here. You can change the implementation of a concrete class. Of course, I changed the implementation through inheritance. I derive this class, and I'm able to override methods as long as I have the virtual keyword in that method definition. That's also true of abstract classes. I can inherit abstract classes, and here's the difference. The qualifier is different. Any abstract method, you change the implementation or you implement it, but the difference is that you are required to implement any abstract classes. There's no choice there. If you're deriving from an abstract class and you inherit abstract methods, you are required to create an implementation. That is, you're required to take those methods, take those signatures, and put code within that signature. Here, it's a choice. Virtual simply means that there's code or implementation already there, but you decide whether or not you want to change that implementation. When you want to create an abstract class, you need to use the abstract modifier in the class as well as any method or property that you want to make abstract. Remember that when we created concrete classes and we wanted some of those methods to be overridden or have the ability to be overridden in a derived class, we use the keyword virtual. We tagged every method that we wanted to be overridable in the derived class. We tagged it with virtual. This is almost like a virtual method. It's implicitly a virtual method, these abstract methods, because the derived class is going to be overriding them. Abstract methods are only allowed in abstract classes, but abstract methods work similarly to virtual methods. The only difference is if something is labeled as an abstract method, it is required that you implement it in the derived class. When you derive an abstract class and you implement the abstract methods, you need to tag those methods with the keyword or the modifier override. That will tell the compiler that those methods are being overridden from the base class, which is an abstract class. Let's take a look at an example. The top of the screen shows us the syntax for creating an abstract class. Notice the keyword here is the modifier called abstract. Notice within the abstract class, I've got an abstract method. Now the key here is to actually look at the definition of the abstract method. It simply gives you the signature of the method. It does not provide any implementation. You see a semicolon at the end of the line and you see no braces. So an abstract class does not provide the implementation of an abstract method. It only provides the signature. The idea here is that the intent is that the derived class provides the abstract method implementation. Now this class is an abstract class, and it can have both abstract methods, which we have here, and it can also have non-abstract methods, just regular run-of-the-mill methods where implementation is provided. That's why we call an abstract method something like a partially completed class. Some methods and properties have implementation, and some do not. Those that do not have implementation include an abstract modifier in the definition, and also the intent is the derived class will implement that method. Looking at this example, I have an abstract class called employee. Employee has two methods. One method is hire, and it's just a regular non-abstract method. It's got a signature and it's got implementation. The second example is actually an abstract method. Notice there's no implementation here, there's no open-close braces, there's no block around the pay method because it's not implemented. And it does end in a semicolon. So this abstract method has both a non-abstract method called hire and an abstract method called pay. If I were to derive this class or inherit this class, I would be required to override this method. If I don't, I'll get a compile error. The way that I would derive this method is I would include override in my derived method. So abstract is a modifier that's used for the abstract class definition. Override is what I use in the derived class to override this method. It's important to remember when it comes to abstract classes that if you derive from an abstract class, you are absolutely required to implement any of the abstract members of that abstract class.